So question 13, in our tutorial 1, we are given figure 1.10, because we have a corrections, show a negatively charged oil drop held at rest between two parallel conducting plates A and B. The oil drop has a mass of 9.79 to the power of negative 15 kg. The potential difference between the two plates is 5000 volts and plate B is set at a potential of 0 volt. Okay, so question A asks, is plate A is positive or negative? So how we are going to know that plate A is positive or negative? Then we are going to refer to the value of potential difference given and also the value of plate B. So the question tells us that plate B is at potential 0 volts, so plate B is at lower potential. And because our potential difference is positive 5000 volts, so we understood that the value of potential here will be 5000 volts. So our plate A is at higher potential, in which the value will be 5000 volts. So, guys, we know that the plate A is at higher potential, plate B at lower potential, so means that plate A will be positively charged and plate B will be negatively charged. So our answer for question A will be plate A will be positive. So our plate A will be positive. Question B, we want to draw a level free body force diagram which show the forces acting on the oil drop. So we want to sketch a free body diagram showing all the forces that acting on the oil drop. So I represent the oil drop with a dot. So what forces is acting on the oil drop? So we understood that. So due to the potential difference in between plate A and plate B, we are going to have uniform electric field create in between the space of the plate A and plate B. Okay, so we are going to have uniform electric field create in between the space between plate A and plate B. So when the charged oil drop is negatively charged, so any charges we put in electric field, it experience electric force. So for this oil drop, because it's negatively charged, the oil drop is negatively charged, so it will be attract towards the plate positive. So it will be attract towards the plate positive, so the oil drop will experience electric force upward. Because it's negatively charged, so dia akan rasa daya tarikan ke plate A yang bernilai positif, ke arah plate A yang bernilai positif. So we have electric force acting upward for the oil drop. And then class, be careful, the oil drop have mass. So this mass, because the mass is given, so for the oil drop we are going to have weight acting downwards due to the mass. Because of the mass, so the oil drop will experience weight acting downward. Weight is given by mg. Electric force is Q, the magnitude charge of the oil drop multiplied with the electric field strength. Okay, so this is the forces acting on the oil drop. Question C, we want to calculate the electric field strength between the plates. Okay, so class, because of the potential difference, there will be uniform electric field create in between parallel plate A and B. So we want to determine the electric field strength E. So electric field strength between plate. So between plate we create uniform electric field. So the electric field strength between parallel plate is given by the potential difference between the two plates divided by the separations of the plate. So we have the potential difference is 5000 divided by the separation between the two plates is 2.5 to the power of negative 2 centimeter, change it to meter, or calculation in SI unit. So you might pause the video to do the calculations. So if you calculate correctly, you should get the electric field strength create between the two plates will be 2 to the power of 5 Newton per Coulomb. Newton per Coulomb. Okay, then we solve question C. We're done with question C. Then we proceed to question D. We need to calculate the magnitude of the charge Q on the oil drop. So we want to find what is the magnitude of charge carried by this negatively charged oil drop. So we want to find Q. So class, we want to find the Q for the oil drop. So we understood from the relation, we can determine the value of Q by relate it with the electric force acting on the oil drop. So how we are going to relate the electric force with the weight? So we are going to apply Newton's law. So which Newton's law we need to apply? We have to refer to the condition given in the questions. So if you refer to the questions, the oil drop is held at rest. The oil drop is held at rest. See the keywords at rest. So at rest means we are going to apply Newton's first law. We are going to apply Newton's first law. So because at rest, we're telling us that the summation of force acting on the oil drop will be 0. So refer to the free body diagram that we already sketched in question B. So we have electric force upward, weight downward. So we have Fe minus the weight equal to 0. So the electric force is QE. Then I rearrange. So the weight, I bring it to the right side. So weight is equal to mg. So I'm going to have QE equal to mg. Then we can calculate the Q. Then we can determine the value of Q because the value of E is already calculated in previous question. So the value of E is 2 to the power of 5. The mass of the oil drop is 9.79 to the power of negative 15 kg. The G is 9.81. So pause the video and do your calculations. You might get the value of Q should be 7.8 to the power of negative 19 Coulomb. Okay, so then we solve our question 13.